Now imagine you and your friend are both depositing money into the same bank account at the same time. You deposit 1000 rupees, your friend deposits 2000. Ideally, the account balance should become 3000. But sometimes, due to both accessing at the same time, it may only show rupees 2000 or 1000. Why? Because both updates clash. This is called a race condition. We need a way to stop two threads from accessing the same resource at the same time. This solution is called synchronization. Now, let's see more in detail. What is synchronization? Synchronization in Java is the process of controlling access to the shared resource by multiple threads. Now, why synchronization? Synchronization is important to prevent data inconsistency, to avoid race conditions, and to make threads execute in a safe way. Now, how to achieve it? It can be achieved by using synchronized keyword in Java. Now, let's see the syntax for it. Now, you can see the syntax: synchronized, return type, then method name, parameters, curly braces, and inside that the code block part, and then closed with the curly braces. Here, synchronized keyword is the main hero. It tells Java, hey, only one thread can enter this method at a time. And if another thread tries to call it while one thread is inside, it has to wait. Then we have the return type. This is just like a normal method. It could be void, int, string, or anything else. Synchronization does not change the return type. Then we have the method name with the parameters, the name of your method and any inputs it take. Example, it can be increment or deposit, int, amount, etc. Multiple threads may call this method, but only one thread at a time can actually run inside it. Then we had the code block part. This is the critical section. Now this contains the shared resource, the part of the code that must be not accessed by the multiple threads simultaneously. For example, it can be like updating a bank balance, increasing a counter, or writing a file. Now this was the syntax. Let's see the code now. Now, I'm directly pasting the code here to avoid extra time. So, let's write. Now you can see in line number 4, private int count is equal to 0. This is a shared resource, that is an integer that multiple threads will update, and it's initially as 0. Without synchronization, both threads might update it incorrectly. Then we have used the synchronized keyword here because it ensures only one thread updates at a time. Then we have written void increment with count plus plus. Now if thread 1 is running with increment, thread 2 must wait until thread 1 finishes. This prevents race condition where multiple threads try to update count simultaneously. Then we have public int get count and return count. This is a simple getter method that returns the current value of the count. We will use this after all thread finishes. Then we have written public static void main string argument and then throws interrupted exception. This is the main method, that is entry point of the program, and we have added throws interrupted exception because we will use join which can throw this exception. So let's write in the main method. Now you can see in line number 16, sync demo counter is equal to new sync demo. Here we are creating an object sync demo. Now both threads will share this same object and mean that they will both update the same count variable. Then we have written our thread T1 is equal to new thread and with the for loop. Now what is this? Here we created our first thread, that is T1, using the lambda expression. Now inside it we have loop running for 1000 times, calling the increment each time. So it tries to increase count by 1000. Then again we have thread T2. Now this does the same as T1 and increases count by 1000. Then we have written T1 dot start and T2 dot start. Now what is this? This will start both the thread at the same time. They will now run concurrently, not sequentially. If synchronized wasn't there, race condition could occur and the count might end up with 2000. Then we have T1 dot join and T2 dot join. This tells the main thread that wait here until thread 1 finishes, thread 2 is not allowed. So the main thread waits for both T1 and T2 to finish their work. And then finally we have our print statement that counts the final count after both threads are done and print the final count. So we will talk about lambda expression further in the next topic. For right now, let's save the file and run our code. And you can see final count 2000 came as the output for thread 1 1000 and thread 2 1000, and then the final count is 2000. After both threads are done, this prints the final count 2000 because each thread increments 1000 times, so total 2000. Now the key idea is without synchronization, final count may be less than 2000 like 1950 due to lost updates, but with synchronization final count will always be 2000. Now here is a question for you all. If I remove synchronized from increment, what do you think will happen to the final output? Will it always be 2000 or could it be sometimes less? Comment your answer below. And for today, this was our session. In the next class, we will learn something more interesting in Java. So stay tuned.